Now let's check out one of these law of cosines when we have two sides and one angle. Now this is going to be, again, very similar. I'm going to be doing kind of some basic solution steps, but there is something at the very end that I want you to watch out for and be careful of. So the first thing that I'm going to do is, if I have two different sides, I'm going to use the law of cosines to solve for that last side. This is what I usually do, is I start with finding all the sides, and then I go and work for the interior angles. So I'm going to use the a squared is equal to 9 squared plus 12 squared minus 2 times 9 times 12 times cosine of 25, which again is just one of those formulas, but since I'm solving for a, I need to do this by solving for a squared. It gives me a squared is equal to 29.2375, which means when I take the square root of both, I get that my side a is going to be 5.4072 meters. And again, meters just because that's what my other two sides are in. Now from here, I'm going to go and switch over and use my law of sines. Now you can use your law of cosines here if you would like to, but I find law of sines is actually a little bit easier because I know sine of a and I know a. So because I know this angle a and I know side a, that's going to allow me to solve for b. So I get sine of b is equal to 9 times sine of 25 over 5.4072, which gives me a b of 44.7. Now, this is where I want to call your attention. Because remember, if this is going to be smaller than 90 degrees, that means that I could possibly have another angle. I could have 180 minus 44.7. So I could have b is equal to 135.3. Now here is where I need to be careful, because I know that b is not my largest angle. So c should be my largest angle because it is my largest side. So if b were to be 135.3, which is the other possible solution to this, I know that that is going to essentially break my rule of my triangles, because I can't have 135 as one angle, 25 as a second angle, and for this one to be smaller than the third angle. So we have two possible solutions, but because theta c is required to be the largest angle, due to be the opposite of the longest side, b equals 135, which would be our secondary possibility here, would not create a valid triangle. So be a little bit careful here. So I'm going to assume, just based on these kind of laws of logic of trigonometry, that my b is going to be my smaller angle of 44.7. Now once I know that, I can solve for c. c equals 180, because there's 180 internal degrees, minus 25, or my theta a, minus my theta c, is going to give me 110.3, which, because this is the largest angle attached to the largest side, this makes sense. Okay? So again, when we are going to be working with both angles and sides, I would always find the side first, and then if you would like to, you can switch over to the law of sines to be able to solve for, whatever interior angles that you might need.